This current AI hype makes it downright impossible to separate delusion and even lies from reality of the situation, especially for aspiring engineers or people earlier in their tech career. In my 23 years experience as an engineer and also engineering manager, this is the wildest hype cycle that I've ever seen. And even myself, I still have some fear, uncertainty, and doubt about the future of software engineering. So is it still a good field to get into, or is it true that AI is coming to take all the jobs? And the reality is nobody knows, and the people who claim to have the answers are really just kind of reading the tea leaves. That said, I do have some experience-based opinions and thoughts that I think can actually help you in your decision-making, like what you want to do with your tech career. And no, it is not all doom and gloom, but yes, you do need to take this disruption seriously. So I'm sure you've all heard of Devin, which is the world's first AI software engineer. And there's a guy, Carl, he runs a channel called Internet of Bugs. And it's a great channel. He does a really good video on this already. You should go watch that. So I'm not going to go dig into debunking Devin, but it's important for early career or really anybody to understand the lengths that these companies are willing to go to generate the hype, to be first, to get the funding. For example, one of the tasks that Devin did was only like a 30-minute task for a senior engineer, but it took an actual engineer working with Devin like well over a day to complete it. The tasks that were assigned to Devin were far from random. They were kind of hand-selected for simplicity and curated. Another example is OpenAI's latest model, GPT-4o, where they had a pretty cool demo that they released. The demo showed a human being interacting in real time with the 4o model, and the voice was very human-like and was responding like in real time. And it turns out that that demo also is rumored to have been faked completely. They rushed this to demo so they could disrupt Google's announcement when they were announcing, I think it was a new Gemini release. And they were talking about, well, this is, a few weeks away. Well, here are months later and it's still not released. The other thing about 4o, which I found, was it claims to have achieved a 90th percentile on the unified bar exam. But another study that was done on that study showed that OpenAI actually like rigged the test and kind of pre-trained GPT so that it could pass. And when they actually ran it through a more scientific way, that got a 15th percentile on the exam. All these big companies are all guilty of this. Like Google, for example, has some really hilarious screw-ups. And they've been faking demos ever since GPT came out, like 2023. But they have some pretty hilarious search results, like when they implemented Google Bard into their search page, somebody asked for fruits that end in and it responded applum, bananum, strawberrum, tomatum. You've probably already seen these memes out there, but my favorite was coconut, which doesn't even end in at all. And then somebody asked it, how many rocks should I eat? And it said, according to geologists at UC Berkeley, 1 small rock per day. Companies have rushed to market these LLM-based AI systems that are just flat out giving wrong advice and just making stuff up. Andy Jassy, who is the CEO of Amazon, his tweet on the effectiveness of Amazon Q, and he claims to have saved 4,500 developer years, not months or hours or days, but years. Quick Google search for Amazon Q effectiveness. There's quite a lot that's been written about it, and it's really not that good. This is the same Amazon who, those Amazon Go stores, if you remember those, where you would just walk in and grab the stuff off the shelf and drop them in your cart and just walk out, and it would charge you automatically. And it used cameras and AI, machine learning, and all this fancy tech. And it turns out, like in the background, there were just real human beings that were actually just watching you with cameras and adding stuff to your cart and then charging you for it. So, but they lied, just like boldface lied to people about their capability there. And there's just really no incentive for these companies to stop lying to you. They just want to be first. So also regarding hype, just beware of sort of the anti-hype. So there's a lot of hype on the other side too, where you have a lot of very skeptical engineers mostly who make claims like, well, The LLM is just predicting the next character. It's not actually intelligent. This to me has always been just a kind of a foolish reductionist argument. You could make the same reductionist claim about the human brain. Well, the human brain is just a meat bag that is responding to stimulus with electronic signals. Okay, well, yeah, but somehow magically that is the engine of intelligence in humans. So the next point to consider when thinking about how AI could disrupt your future plans in your tech career, rewind to like the late 90s. And digital cameras were actually just now starting to become popular. And I actually kind of remember this time. There was kind of a whole industry around film cameras. And obviously digital cameras came in and started to disrupt this. And then when you had the iPhone come out, suddenly everybody had a decent camera in their pocket. All those jobs around the physical film industry, all those cameras, they went away almost within a few short years. So major disruption resulted in job loss. However, this is the important point, and it relates to AI. Hopefully you'll see how. Look at what rose from the ashes of the film industry that couldn't have been possible without digital cameras. The entire creator economy could not have existed before digital cameras. I mean, think about Instagram and YouTube. You know, all of those platforms. They weren't even dreamed up back then. And these aren't just applications; these are entire ecosystems and platforms where almost like an industry in and of itself, where other things are built on top of them. You know, I'm using multiple paid software subscriptions to make and produce this video, and my thumbnail tools and all that stuff that people had to make and build that stuff. So all of the software type jobs that came out of that disruption. So yes, we lost jobs in one industry, but it ended up creating a lot more jobs and a lot more opportunity kind of after a few years in the longer run. And on top of that, we democratized media generation, thanks to the digital camera, digitizing photo and video. So it provided access to so many more people to actually be able to generate and monetize content. Here's another way of looking at disruption. So I'm going to look at my notes here and I'm going to read off a bunch of job titles, very engineering, kind of software engineering related job titles. Front-end developer, back-end developer, full-stack developer, iOS and Android developer, systems reliability engineer, SRE, cloud architect, InfoSec engineer, DevOps engineer, data scientist, UX designer, machine learning engineer, data engineer, AI researcher, BI developer, automation engineer, and then like ancillary roles like agile coach, scrum master. You've probably heard of all these roles. Well, what's interesting is none of those roles existed when I graduated college in 2003. Some of them kind of did, like we had web developers, but all of this specialization kind of came out of that internet boom and bust. As we learned more about how this technology could solve problems, the body of knowledge grows, the type of problems we're solving become more complex, the need to specialize just also grows. So it's like medicine, 50 years ago, you just had doctors and surgeons and dentists, but you didn't have these highly specialized fields where you had a doctor for a very specific, body part or even a very specific type of disease. As we're able to solve bigger medical problems and the body of knowledge grows, the need to specialize grows because human beings can't, you can't have a doctor who's a brain surgeon and who delivers diabetes care, all at the same time. There's just too much knowledge there. So the same thing has happened in technology, and we've just seen continued explosive growth as the complexity rises. So the point I'm trying to make here is don't be afraid of disruption, but you do need to be aware of it and be ready to pivot very quickly. In the past, at least, disruption has almost always led to more opportunities down the road, especially for people who have a continuous learning mindset. So all of that to set some historical context for disruption, for AI, where we are now. And for those of you who didn't come up in the last 2 or 3 decades, you maybe not experienced that before. So is AI a disruption? Well, yeah, it's a massive disruption, at least on the order of magnitude of the iPhone. It could be more of a seismic shift even in the industry. So does that mean AI is coming to take software engineering jobs? And what's really important for you to understand is engineering is so much more than programming, than coding. Hands-on keyboard writing code is actually, I'd say, less than 50% of the job of an engineer, especially when you get into more senior levels. Engineers, what do they do? Well, a big part of it is requirements analysis. So there's a lot of trying to tease out what that requirement, what the intent of that requirement is. It's a huge part of the role, is understanding what the needs are first, and what is actually feasible to do with the technology that we have. And related to that, once we have sort of an idea of what the thing should do, we have to plan that effort out. Who do we have on the team? What are our skill sets? What are some of the business constraints, like on as far as cost and timeline? And we have to take all that into consideration as we're developing. And then you have the architecture and the design itself. So making sure you're building a system that is scalable enough, for whatever the future needs might be, that it works with your existing ecosystem, all of your patterns of integration between subsystems, all the debugging that happens. That is not just hands-on keyboard. It's a lot of research and digging and setting breakpoints and logging, logs, and all the detective work that goes into trying to find and resolve a problem. Then you have the testing aspect. There is manual testing from a developer. You've got a gut feel. You're poking around. You're trying to break things. When stuff breaks and doesn't go well, there's incident response and management. So root cause analysis, trying to figure out what went wrong. How do we keep it from happening again? All the security that comes with what we do now as engineers, and other types of compliance with regulations that we have to make sure are implemented in the systems. Upgrades and migrations, which seems like it's most of what engineers do these days. Research, staying on top of what the latest tools are, what the newest versions of things are, how to, making plans for implementing those. Continuous improvement of the system itself, trying to find ways to automate manual tasks, fixing, recurring issues in your process as well as the actual technology, providing input into the product strategy and design and the user interface design as well. And just all of the messy, hard to quantify work that comes with being a, quote, knowledge worker, working together with different roles to come up with solutions, because no one person can have all that knowledge. So all of that to say, hopefully that proves to you, if you've never been in an engineering position before, that engineering is way more than coding. So when we talk about AIs that can code, that shouldn't automatically translate into AIs becoming software engineers. So when I say this next thing, hopefully it doesn't send you into panic, but I think coding is actually dying. And nobody can really say like what that timeline is going to look like, but depending on what domain you're in, some domains will be affected differently. I'm mostly in like full stack web development, distributed systems development. And I can see a time in my career where I won't really have to code front-end applications anymore, where the tooling will become good enough. You'll have front-end designs that you can generate using a prompt, and then that tool will be able to generate React code, and then you'll have another tool that will be able to generate unit tests and things for the business logic. And this will happen kind of through prompting with a human being connecting it all together. I don't think that that's science fiction. I think that that's probably where we'll see this go. Now, I think engineers will have enough time to kind of learn these tools and deploy them. One way I've been thinking about this is like how the automobile impacted horse-drawn carriages, where there was obviously a huge disruption and people didn't really need to know how to raise horses anymore. And then this whole new industry kind of sprung up around cars and mechanics and people racing cars. And it really just created so much more opportunity down the line thanks to that innovation. But there was a period of time, I'm sure, that was very painful for people who were displaced. So what makes me think that we're actually going to have more time than maybe the hype leads us to believe to kind of adjust to this change? And one of those is just paying attention to what's going on with LLMs, and I highly recommend you stay close to this space. But what seems to be happening with LLMs is we're starting to plateau. We need more data, and we need more energy than we actually can produce cheaply. There's experimenting with AI-generated data. You see companies like Tesla who have this massive data sets from their autonomous vehicles or from all their cars, So you see like these proprietary data sets are going to become more and more valuable because basically like ChatGPT was trained on the internet. There's no more internet for it. It reached the end. So with this sort of plateauing in LLM capability, at least for the time being, until there's a ton more investment, what you see is an LLM by itself is not enough to just write good code. It is not good at determinism, which you can see like even when it's generating images with like 6 fingers, because it's close enough for you to tell it's real, but it's also wrong enough for you to tell that it's fake. And in code, like that's not good enough. 95 or 90% isn't good enough. We need to be able to specify the system behavior with 100% accuracy. So until the LLMs can like make another order of magnitude jump, the hallucinations are really kind of shutting down this idea of the LLM just by itself being able to do all of the coding. So that's why I think is going to give us some time to deploy and learn these new tools that are being built around LLMs to make engineers more effective, to learn how to have these tools like do some of the crap work that we don't want to do, and it's to make our lives better. So this is, maybe it's a little bit of hopium, but it's kind of where I'm sitting right now. So as impressive as AI coding has become, I don't actually think that's where the main paradigm shift is coming. So you may have seen recently where Google released a research paper where they had an AI generate a playable version of the game Doom. So when you actually think about what is happening in this research project, where a playable game is being created, but not by a person who sat down and wrote code, or not even by an AI who sat down and wrote the code to build the game is actually being generated and run by the neural net itself. So it's just like when if you're in ChatGPT and you say, you prompt, give me a screenshot of the first person in Doom with this type of monster and holding this weapon. And then this prompt happening in real time. And the neural net actually predicting the next frame based on the current frame and based on it's been pre-trained on this game. So it's a whole new way of like developing and running software. I really think when you fast forward this, and who knows how long, how many years or decades, applications themselves will not need to be built by people anymore. The AIs themselves can generate and run applications. You send in a prompt where, hey, give me an application that I can use to make my house payment. And the AI will just give you an application that lets you select your account and click a button and schedule your payment. So a person wouldn't have to pre-generate that application and install it. So where does this leave you? Let me know in the comments. I'd love to hear from you, and I respond to every comment. If you are currently in the stage of your career where you're re-educating or getting an education, I don't think the comp sci programs are going to be able to keep up with this. I also don't think that the tech bootcamp programs are going to be able to keep up with this. So what that means is you really need to be in the driver's seat of your education and just really stay close to this AI stuff. Learn how to use the LLMs, learn how to program against them. If you're the kind of person that is comfortable more on the edge, continuously learning, you like a challenge, you want to get into technology for maybe you want to make more money, but also you really enjoy learning new things. And it kind of scratches that itch for puzzle solving, and you like to be detail oriented. My prediction is that there will be a place for you in whatever this future market looks like. And if you need more help deciding, do you want to go into engineering or you want to stay in engineering, I have another video here that I go into detail outside of just AI as well. So anyway, I really appreciate you watching and your comments and your engagement in the channel so far. It's been super encouraging. And I just want to say, just because the software industry is broken doesn't mean that we have to be. So thanks a lot. See you next time.